LINQ is a technology that gives you the ability to query data from the C# language. And by data, I mean you can query objects that are in memory on the heap, objects you've persisted into a database, objects behind web services, objects in XML, objects anywhere there is a LINQ provider. And every application needs to query data, even if the query is only sorting some existing objects you already have on hand. To do this, LINQ provides over 50 query operators that you can use. These operators handle everything from sorting, joining, grouping, partitioning, projecting, and of course, filtering, so you can filter and find just the data that you want. For instance, if you have a collection of employees, you might want to find just the employees who are engineers. So the first hurdle to overcome when building query features into a statically typed language like C#, where every object has a definite type, is what will provide these query features. For example, the LINQ operators are defined as methods, and we know that methods have to be associated with a type. So if we want a method named where, which will act like a SQL where clause to filter data, take an input sequence and return some sort of subset of that is the output sequence, then on what type will this method appear? Now, since LINQ is supposed to support a variety of data sources, everything from in-memory data to data that is inside of a database, imagine if we defined a new type, an interface type called iSequence of T, where iSequence can hide where the data is coming from. If it comes from a database, then someone will have to write a SQL sequence of T that implements that interface and knows how to talk to the database and knows how to take that where method invocation and turn it into a where clause inside of SQL Server. The drawback here is that to implement this properly, then iSequence of T will need to define a method for every query operator that we want. And of course, any class that implements that interface, anyone who wants to write a LINQ provider, they would also have to implement all the methods defined by iSequence of T. And the big problem here is that if Microsoft wants to introduce new operators over time, as they have done, then that's going to break any existing clients that have implemented that interface. We've learned in this class that when you implement an interface, you have to provide all the members of that interface in your class definition. If not, it is a compiler error. So when someone adds a new method or a new field or a new property to an interface, you have to change your code and recompile in order to get things working. So adding a method can break an existing client. And this makes this interface approach a little bit tricky. And ultimately, Microsoft decided not to define a new type to hold all of these LINQ operators. That approach is just not flexible enough. It's not scalable enough. It doesn't support change over time. Instead, Microsoft took a different approach and added a new feature to the C# language.